This is the video tutorial that goes with lesson 8.2. Right at the start, we're going to look at the previous homework, which was from assignment 8.1, and we're going to start on this first question. So for each set of data, find the curve of best fit. That's kind of like one of our key phrases for these questions. So we know that we're typing in the data into a table on Desmos, and then we're going to find out what the rule is. Then use your equation to answer the questions. The table below shows the advertising expense of the company compared to the company's revenues. All numbers represent thousands of dollars. Now that means then that when it says 20, that does not mean $20. That actually means $20,000. So that's going to be kind of important as we're doing our question. Now, for the benefit of people who missed last lesson, when you're doing these questions, you're going to click on the plus symbol on Desmos calculator, and then you're going to select table. Make sure it says X1 and Y1 in the table. If it says X2 and Y2, this won't work. Enter the values, just copy them from the table. Click the magnifying glass so you can see all the points. And if the graph looks U-shaped, or you can see a curve in there, it might just be the left or the right-hand side of the curve, then you're going to type in the rule Y1 tilde AX1 squared plus BX1 plus C. When you do that in Desmos, it gives you the three values. It'll tell you what A, B, and C are. A is the number of X squareds, B is the number of X, and C is just a constant term, as in just a number by itself. So if you ended up with 4, 1, and -5, that would mean that the answer is 4x squared plus 1x, or just plus x. And then on the end there, you'd put -5 because it says -5. So even though it says plus C, if you add -5, that's just the same as subtracting 5. So you could fill those ones in. Now for that table, whoops, I've already typed in the values, and if we click on our little magnifying glass, there we go, we can see those. You just turn that off for a second. Not a perfect curve for this one, but you can certainly see that it's going up and it's coming down again. So I'm going to use my quadratic curve. So I'm using my Y1 tilde. And then we look at these numbers at the bottom here. So -7.66619, that's how many X squareds we have, and so on. Now you can round a little bit if you like to, that's fine. So that's what I did here. I rounded to a couple of decimal places. And then let's go back to that first question so we can see what it says. What is the revenue when advertising is $40,000? So first of all, advertising is in my left-hand column, so that's my X value. And also when it says 40,000, remember these are already in thousands. So actually my X value for this would just be 40 and not 40,000. So as I go back, I type in X equals 40. And right now I don't see that line here because I only go up to 36. So if I move this across a little bit, there we go, I can see it here. And I'm just moving my picture out the way a little bit because sometimes it's easier just to zoom in and zoom out. There we go. And I'm looking for where do these lines and curves intersect. So if you click on one of them, you'll notice it puts a dot on the intersection. And 40 was the number we typed in. So the answer we're looking for is the other one. So 5,004. That would be how many dollars that you would spend. With the revenue generated for this question. Now, question 3 was confusing because there was actually 2 columns here. But basically, column 1 and column 2 are the same information. It's just one of them says years, and one of them says how many years since 1990. Now, most people actually chose just to ignore this one and go with these 2, probably because they're next to each other and they're smaller numbers. So I'm going to focus on that one. But you could certainly do the question the other way, and you certainly will still get a curve. You will just get slightly different numbers as you're doing it. Oops. So, I meant to change that to using columns 2 and 3. So you can see I put 4, 6, 8, etc., down the side here. And here's my numbers: 0.41, -1.51, and 49. So that would be how many X squareds. That's how many X's, and that's just the number by itself. And the question said, let me just go back. What will be over the age, how many Americans will be over the age of 100 in the year 2050, round to the nearest whole number? Now, a lot of people saw the number 100 and immediately said, oh, X equals 100. Well, there is a problem with that. If we look at what the X value is for this, it tells you here. This says years. This does not say age. This table includes people who are 100 years old. So 100 is not the important number for the prediction. This is the important number, 2050. Now, we can see that years is in the X value, but we don't put X equals 2050. This is how many years it's been since 1990. So 2050 is 60 years afterwards. So for that reason, when you're typing in your rule, you would type in X equals 60. And as I go back here, that was the original table if you used years. There we go. There's my X equals 60. and then I can just click to see where it crosses, click once, and then click for a second time. So about 1,470 approximately. But remember, that table for population said this is actually in thousands by itself anyway. So it's not 1,470. We actually have to add 3 more zeros on to make it into thousands, meaning actually it would be 1,470,000. We don't talk about it much in this class, but really this is not a good idea. Look how close these points are together, and look how far we're extrapolating. That's to extend the data into the future to make a prediction. That's probably too far away to be able to judge accurately, so that's probably not going to be an accurate number. And question 6. Now, this is not exactly the same question that you have on yours. It's very similar. Yours actually has -46 here. So there's a slight change. I've changed this to -4. So it tells you it's a quadratic pattern, and we have to figure out what this number is here. Now, the problem is you're typing this in. You might want to type all this in and then put the question mark. Now, if you do that, what you'll notice is it doesn't like it. It gives you that little warning symbol. Now, you might just choose to take it out. And if I click on my magnifying glass, it will actually draw through all the points that I have. Now, my personal recommendation is don't have anything where there's no single value there. Now, I'm noticing actually this has 3 values. And I'm actually missing this one here. So -2, -4. I actually missed one of the values as I was typing. So just make sure you do have them all typed in. And yeah, I typed in my rule because I could see this was a curved graph, and I would have my rule here. Now, the reason we skipped out 10 at the start is it's because this is actually the prediction question. When x equals 10, I want to know what is the value of y. So for that reason, I typed in x equals 10. There we go. Now I can see it. And I just want to see where do they cross. Oops. So click and click on the intersection. My answer is 32. That's not the answer that you get because I did a slightly different question, but you should be able to apply that to your question as well. The one with the question mark is definitely an SOL type question, so make sure you understand how to do that question. Now, lesson 8.2, strictly, we're going to go straight into our test review. Now, for the first question, the table was already written out here. So I had this mostly done for us so we can speed this up a little bit. So just a reminder, to enter the table, you're going to click plus, you're going to click table, and then you're going to type in all the values, making sure it says X1 and Y1 at the start. I only see one of my points, and that's because I haven't clicked my magnifying glass yet, and then I can look to see what's happening. So certainly looks like a curved graph, so I'm going to type in my rule, Y1 tilde, which is shift and the button above the tab if you need to, or on your Desmos calculator, you can click ABC, and you'll see it down here. And then it's AX1 squared, so AX1 squared. And if you're using the Desmos keyboard, you can just use this button here. And let me keep going, plus BX1 and then plus C. There we go, and that's starting to look a little bit more like what it's supposed to look like. So my 3 numbers with a little bit of rounding, I can see the first number for A is 4.75. Technically, with the next number being 5, this really should be 4.76, but sometimes we miss those roundings. So I'm going to pretend it's 4.75 for right now. And then I'm going to look at my answers. And if you notice, this one here does have 4.76 as my value for x squared, whereas none of the other ones do. And in fact, these two don't even have an x squared in them. So just remember, the ones with x's are just going to be straight lines, either like this or like this. So you could see from the pattern that that wasn't true for this question. So I could have eliminated those ones straight away. On question 2, I put this question in kind of jokingly at the start. The person who made this question actually made a mistake. Most people, when I ask them how many in class, how many points are there, they would say 5, and then we go 6, because they would finally notice this bottom one in the last corner. So actually, there are 6 points in this question, but the person who created this question missed this point on their table and made the answers based on these 5 points. So we're just going to pretend that that one's not there, and we'll be careful about it. So yeah, they missed out this value here. So the table should look like this. As I read down, I can see this is 10 and 50. And I think as we move across, actually, it will actually have some of those other values in for us. There we go. So you can see this third point goes from 40 to 200. This one here goes from 50 and then across to 150. And the last one, 60, and then across to 50. As I type them all in, just as I did before, type in your rule. So again, might want to just click on that point there just to check to make sure that it is a curved shape before we do this. And this upside down parabola, remember this means negative x squared, and you can actually see that here, negative 0.25 x squared. Let's take a look at what the answers were. And there we go. I can see this negative 2.5 x squared. I also saw negative 100 as part of the answer as well. There you go. So you can actually see kind of easily that that's going to be the answer. So whoops, let me fill it in there. Answer B. And notice actually 2 answers didn't even have a squared in them because they were just straight line graphs. So that's how we can check when we're doing our questions. So think about, is it a straight line graph or is it a quadratic graph? This one's a pretty straightforward one. I let students try this one in class by themselves. As you're typing this one in, if you want to pause the video, you can certainly do so and try it. As you're typing in this one and you type in your rule, you'll first of all notice that it is quadratic. And actually, you'll notice it's that upside down U shape as well. And for that reason alone, without even typing anything in, I know that it's this answer here. These two are straight lines because there's no squared. And 6x squared, that's positive 6. I know that gives me my U shape. If I did want to type in the rest of the table, I kind of have it here. Got to type in my rule again. That's bx1 plus c. And there you go. You can see that negative 6 there. Oops, just click on that zoom in just so we can check again. But you can see my upside down parabola. So I know that it's definitely negative x squared for this one. And those were the answers. So yeah, clearly D for this question, as you could see from those numbers. Question 4, this is a drag and drop question. We would take each number and we would drag it into here. We're not going to do it like that today though, not while we're practicing. So that missing number, notice the first column. Let's just go back because this is a horizontal table. This goes in our first column. This goes in our second column as we're entering them. And then I can type in my rule again, y1 tilde, ax1 squared plus bx1 plus c. And we'll take a look at those numbers. There we go. So about negative 58 for the first number. So let me move across to my answer. Oh, a little bit small. No negative 58, but certainly negative 57 would be the closest. And make sure you're paying attention because they did put a negative 57 and a positive 57 here. So if we'd only looked at the number and not sign, we could have made a mistake there. My second number, 145.8. Don't see that exactly, but that's certainly the closest number. And then from your last value, 7.7, which is pretty close to 8. So we would drag that number into here. So they're not exact, but often in questions it will say, pick the answer that is the best answer. And for that reason, that's why you would choose these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values here. No table, we got to create our own table. So we got to do it by reading each value like we did earlier, reading to the X value and then reading to the Y value. But for some of these, we are going to have decimals. And also notice my answers here look very different from how I've had my previous answers written as well. So I did the first 3 values and you can see I started to fill these in here. So -4 and -4.5. And this actually says 3, 1 here, but you can see actually the table says 3 and 0.5. So just to show you why, there's -3. And you can see it's between 0 and 1, which is why it's 0.5 and not 1 as it says in the question there. You were then supposed to try this point, and this point. And if you did that, you should recognize those numbers in the table here. This was 4, 5, and 6. And just to check you do have all 10 values as you're doing this. Now, if you can, look at the points that you have plotted and also go back to the picture and see if it looks like they're basically the same. That looks pretty close. That one looks pretty close. Now, to check which is the correct answer for this one, I don't want to really multiply all these out because that's going to be a little bit complicated to do. I just want to check how close they are to these points. So I'm going to have a look at the first one. That looks pretty close. Now, as I look at the second one, I can see that's not as good. So I know it's not that answer. My third answer looks kind of similar, but I noticed that the graph is to the left of all these points and also to the left of all these points as well. So I don't think that that one's quite as good. And then as I look at my last answer, I can see that this one goes through actually these points here. So it's a lot closer to the line than what the first one was. So I'm going to pick that one as my answer, and that's how you can tell which is the closest one. So notice I didn't actually type in the rule at all, didn't type in the y1 tilde thing. I just checked each answer individually just to see which one was actually the closest one. Now, the other thing that we covered in this one as well, as we've been talking only about quadratics, at the start of the unit, we did mention the fact that, hey, we did this before with linears. So here's the rule for quadratics. Here's the one from linears, and it's just that little recap of making sure we understand what we're doing on these questions. So when we see a table, it might not be immediately apparent which is the correct one. So you're going to type them in just like you did before. And as you're looking here, you can kind of see straight away, this is a perfect straight line. So I would want to type in my rule, y1 tilde mx1 plus b. And when you have just two numbers, the first number is the number of x's, and the second number is just the number by itself. So this would be negative 2x plus 4. If I look at the second question here, same thing. I'm just going to type it in because then I can see better. And you can see straight away, you can see that U shape like we've been looking at. So that's going to be the y1 tilde ax1 squared one. Notice it will let you come up with a line of best fit, but notice how poor that line is. This point's way above, this point's way below, and then this point's above again. So we're not really very close compared to what the real picture should be. And then there were a few for people to try, but that was really the essential thing. When we take the SOL, we've got to make sure, is it a straight line or is it a curve? For every question in this, on the first test, it will be a case of, it will be a curve because it's quadratic, but just to make sure you're looking out for both. And that does it for this video, and we'll stop there.